Hello biochemistry students. In this video we're going to take a look at what are some of the interactions the amino acid side chains can have with each other. Now, as we take a look at the side chains, which I have in blue here, this is serine and this is asparagine. The amino acids are the same up on top here. The only thing that makes them different are these side chains. Now these side chains can interact with each other depending on their intermolecular forces. So for example, here we have a hydroxyl group, oxygen and hydrogen. This is very electronegative, and so we would recognize this, hopefully, that this is polar. Over here we have asparagine, and asparagine has a carbonyl group with an electronegative oxygen, so this here is polar. And then here we have nitrogen, which is also very electronegative and can form polar bonds. And so the interactions between these side chains, it's going to be dipole-dipole, and that is we've got two polar side chains like this, but then also we could have hydrogen bonding. Now for hydrogen bonding, we need to have very strongly electronegative elements and hydrogen. So for example, here we have nitrogen and hydrogen. So these here can form hydrogen bonds, and here we have oxygen and hydrogen. I'll just go like this here, oxygen and hydrogen. And so this here could also form hydrogen bonds. So asparagine and serine, their side chains can have dipole-dipole interactions because they're polar, but they could also have hydrogen bonding because of the nitrogen-hydrogen and oxygen-hydrogen. So if we see those, we can recognize that these side chains could do hydrogen bonding. With these two amino acids, asparagine and lysine, we're going to take a look at side chain ionic attraction. And so with these two side chains here, written in blue, and this zigzaggy line is because I'm too lazy to write out the CH2 groups. There'd be a carbon, 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 and then down here we have an NH3. All right, so what's happening here is we have three hydrogens around this nitrogen, which makes it electropositive, just slightly a positive charge. And then over here we have asparagine, which is an NH2. And this lone pair here is electronegative. So we have something over here that is electronegative. I'm going to give this electronegative, and then over here, electropositive. The positive and the negative are going to be attracted to each other. So these two side chains would be attracted to each other by an ionic attraction. So if you're asked what side chains would do this, well, look for side chains that have an NH2 and an NH3. An NH2 and an NH3 are going to be somewhat charged, somewhat ionic, and would be attracted to each other. For a nonpolar side chain interaction, we need to have side chains that are nonpolar. So how do you identify if a side chain on an amino acid is nonpolar? Well, what you're looking for is the absence of strongly electronegative elements, elements such as oxygen or nitrogen. And so here we have alanine and valine. They are lacking strong electronegative elements, and because of that, we would say that these side chains here are nonpolar. And so these two side chains would be attracted to each other by nonpolar attractions.